This video is the 10th in a 10-part series on the Bitcoin Standard, a book by economist Safdin Ammous. This series includes 10 videos, one for each chapter of the book, and this video focuses on the information contained within Chapter 10. Chapter 10, Bitcoin Questions. With the economic basics explained in Chapter 8, and the main use cases for Bitcoin discussed in Chapter 9, a few of the most important questions about Bitcoin's operation are examined here. Is Bitcoin mining a waste? There is a common criticism that Bitcoin mining is wasteful due to its high energy consumption. Bitcoin mining involves solving complex mathematical problems to validate transactions and add them to the blockchain, a public ledger. Successful miners are rewarded with newly minted Bitcoins, providing an incentive for participants. The energy consumption of Bitcoin mining is significant, but it serves a valuable purpose. It secures the Bitcoin network, making it extremely difficult for any entity to manipulate transaction records. This security is fundamental to Bitcoin's operation as a decentralized currency, free from the control of any government or organization. Out of control: why nobody can change Bitcoin. The nature of Bitcoin is such that once version 0.1 was released, the core design was set in stone for the rest of its lifetime. Satoshi Nakamoto, June 17, 2010. Unlike traditional currencies, the production of Bitcoin is not controlled by a centralized authority. Instead, it's algorithmically defined and executed by miners, making it resistant to manipulation. Bitcoin's decentralization and the immutability of its monetary policy are important features that protect it from inflation and political interference. These attributes are seen as a response to the issues of the traditional financial system, where centralized control often leads to economic problems like hyperinflation. Anti-fragility. Anti-fragility is a unique characteristic of Bitcoin's design that makes it not just robust, but anti-fragile, a term coined by Nassim Nicholas Taleb. An anti-fragile system is one that improves or gains from disorder and volatility rather than merely withstanding it. Bitcoin's anti-fragility stems from its decentralized design and the incentivized nature of its mining process. Unlike centralized systems that can be brought down by a single failure point, Bitcoin's decentralized network becomes more secure with more participants, even in the face of potential attacks. Can Bitcoin scale? The question of whether Bitcoin can scale to accommodate a growing user base is a significant one. As Bitcoin has grown in popularity, the amount of transactions has increased, putting a strain on the network's capacity. Solutions proposed include increasing the block size or implementing various technical improvements to optimize the processing of transactions. One of the most promising solutions is the Lightning Network, a second-layer protocol that operates on top of the Bitcoin blockchain. The Lightning Network allows users to open payment channels between each other, where multiple transactions can be made without committing all of them to the blockchain. Only the final balance is recorded on the blockchain when the payment channel is closed. This method drastically increases the transaction capacity of the Bitcoin network. The development of protocols like the Lightning Network offers promising avenues for Bitcoin to scale while maintaining its decentralization and security. Is Bitcoin for criminals? There's a common misconception about Bitcoin: its alleged association with criminal activities. The anonymous nature of Bitcoin transactions has led some to believe that the cryptocurrency is primarily used for illicit activities. However, this perception is not accurate. It's important to note that while Bitcoin transactions can be pseudonymous, which is not directly linked to the real-world identities, they are not completely anonymous. Every Bitcoin transaction is recorded on the blockchain, a public ledger that anyone can inspect. Therefore, with the right tools and information, it is possible to trace Bitcoin transactions back to their participants. According to various studies, only a small percentage of Bitcoin transactions are connected to illicit activities. Most Bitcoin users are individuals and businesses who use the cryptocurrency for legitimate purposes, such as investment, remittances, or as a hedge against inflation. How to kill Bitcoin: a beginner's guide. This section explores 7 potential threats to Bitcoin's survival. Let's summarize each point. Number 1. Hacking. Bitcoin's simple design, vast processing power, and distributed consensus make it highly resistant to attacks. Hacking Bitcoin would require corrupting the transaction ledger in a way that would be costly, risky, and likely detected by nodes in the network. The 51% attack. This involves a miner controlling a large percentage of the hash rate to generate fraudulent transactions. While technically possible, it's economically disadvantageous as it would undermine trust in Bitcoin and decrease its value. Criminals do not want to decrease in value that which they steal. Number 3. Hardware backdoors. It's technically feasible to corrupt hardware running Bitcoin software, allowing outside parties to access or control it. This could damage Bitcoin's reputation and demand. However, as Bitcoin mining grows and diversifies its hardware providers, this risk decreases. Number 4. Internet and infrastructure attacks. Shutting down key communications infrastructure or the entire internet is often suggested as a way to kill Bitcoin. However, Bitcoin is a software protocol that doesn't rely on specific hardware or infrastructure. Disabling all internet connections simultaneously would cause significant damage to society and is highly unlikely to stop Bitcoin. In addition, there is a dedicated Bitcoin satellite that would continue to operate regardless of the entire internet being shut down. Number 5. Rise in cost of nodes and drop in their numbers. If the cost of running a Bitcoin node significantly increases, fewer people will run them, reducing the network's decentralization. This is a serious technical threat, as a network with few nodes could be manipulated or sabotaged more easily. Number 6. The breaking of the SHA-256 hashing algorithm. If the SHA-256 hashing function were broken, all Bitcoin addresses would become vulnerable. The fix would be to switch to a stronger encryption method, but coordinating this change could be challenging. Quantum-resistant hashing algorithms already exist and could be implemented. Number 7. A return to sound money. If the world's banking and monetary systems were replaced with a gold standard, demand for Bitcoin might decrease. However, this is highly unlikely, as such concepts are unfamiliar to most politicians and voters worldwide. The creation of a new form of sound money superior to Bitcoin could also threaten it, but Bitcoin's unique, decentralized design makes this highly unlikely. While there are several potential threats to Bitcoin, its design and the economic incentives surrounding it make it highly resilient. Altcoins. This section discusses the rise of alternative cryptocurrencies, also known as altcoins. Most of these altcoins are essentially cryptocurrencies based on Bitcoin's blueprint, but with certain modified rules. However, these altcoins failed to challenge Bitcoin's dominant position. Despite their surface similarities to Bitcoin, altcoins often miss one key aspect: immutability. Bitcoin's value isn't derived from its speed or user-friendliness, but from its immutable monetary policy, which can't be easily tampered with. Any cryptocurrency created by tweaking Bitcoin's specifications inherently lacks this immutability. As a result, none of the altcoins have been able to replicate the unique combination of features that give Bitcoin its value and staying power. Therefore, the proliferation of altcoins does not pose a substantial threat to Bitcoin. The blockchain technology that underpins Bitcoin is often hyped as a solution to various economic and social problems, but this is largely due to a lack of understanding of how Bitcoin actually works. Blockchain technology is not an efficient, cheap, or fast way of transacting online, but it does eliminate the need to trust in third-party intermediaries. However, it can only eliminate third-party intermediation when it comes to moving a native token of the network itself. In other words, a non-Bitcoin blockchain combines the cumbersome structure of the blockchain with the cost and security risk of trusted third parties. A lose-lose situation. Potential applications of blockchain technology. There are 3 main potential applications of blockchain technology. Number 1, digital payments. Blockchain has been used for digital payments, most notably in Bitcoin. However, Bitcoin's blockchain is not designed for speed or low cost, but for removing the need for trust in third-party intermediaries. For centralized currencies, recording transactions in a centralized manner will always be more efficient. Number 2, contracts. Smart contracts, such as those on the Ethereum network, aim to encode contracts into a blockchain to make them self-executing and beyond the reach of courts and police. However, this raises several issues, including the complexity and potential bugs in code, and the ability of operators to override the contract's execution. Number 3, database and record management. Blockchain can provide a reliable and tamper-proof database and asset register, but only for the blockchain's native currency. For any other asset, the reliability of the blockchain is as good as the party responsible for linking the asset to the blockchain. Thus, a blockchain without a currency is unworkable. While blockchain technology has potential, its real-world applications are limited and often less efficient than existing technologies. For a blockchain to be useful, it must have a native currency and must be decentralized, as in the case of Bitcoin. The economic drawbacks of a blockchain technology. There are 5 main drawbacks, which are obstacles to the adoption of blockchain technology. Number 1. Redundancy. The costly redundancy of having every transaction recorded with every member of the network adds increased costs with no benefit for the intermediaries. Number 2. Scaling. A distributed network where all the nodes record all transactions will have a storage and computational burden that is far larger than a centralized network of the same size, making it harder for effective scaling. Number 3. Regulatory compliance. Regulations were designed for an infrastructure much different from that of a blockchain, and the rules cannot be easily tailored to fit blockchain operation, making it difficult to ensure compliance with all rules. Number 4. Irreversibility. Human and software errors occur frequently in banking, and employing a blockchain structure makes errors more costly to fix due to the irreversibility of cash transactions. Number 5. Security. The security of a blockchain database is entirely reliant on the expenditure of processing power on the verification of transactions and proof of work, and is compromised by operating on a shared ledger, which opens up many possibilities for security breaches to take place. Blockchain technology as a mechanism for producing electronic cash. The only successful use of blockchain technology is for electronic cash, specifically Bitcoin. Other applications such as payments, contracts, and asset registry only work using the blockchain's decentralized currency. Any application of blockchain technology will only make sense if it relies on electronic cash, and disintermediation provides economic benefits. The design of blockchain for electronic cash does not suit other functions, and after many years and many millions of users, it has not produced other commercial products other than Bitcoin. Blockchain is better understood as an integral part of the machine that creates Bitcoin. Please like, subscribe, and check out the next video.